to become the next Sir Isaac Newton or Albert Einstein? Learn from the master. Refath Bari. Watch his videos to achieve your dream.
If you recall, in our previous lecture, what we went ahead and tried to do is go ahead and derive the rotational matrix transformation. Now, we accomplished the first formal step in doing so. We went ahead and converted from Cartesian to polar coordinates, and then we used two of the trigonometric identities to expand cosine of the sum of an angle and sine of the sum of an angle. Okay? So just take a brief moment to go ahead and pause and recollect what we did in our last lecture. And in today's lecture, what I'm going to do is take the second and hopefully last step in deriving the linear transformation for our rotational matrix. Okay? So I'll give you folks a few seconds to go ahead and take a look at what we did previously before we begin to do now. Okay. Okay, so hopefully that was enough time. Okay, let's begin our do now. Okay, so we don't need any of this. Our goal remains the same, so keep that in mind. Okay, and the rest we will be needing for the do now. Okay, so our do now today for this lecture is quite simple actually, and it's as follows. I'll say it verbally because it'll take too long to write down. So go ahead and use the rules, the trigonometric identities we derived in the previous lecture to find A prime and B prime in terms of theta and alpha. So that's the do now. I said it verbally. Hopefully you can go ahead and do what I just said. I'll repeat it. Expand A prime and B prime in terms of theta and alpha. Okay. If you're stuck, you can watch the previous lecture. Hopefully that will give you some hints or guidelines. Okay, let's go ahead and do the do now. Hopefully that was enough time. So A prime is what? I wrote that A prime is equal to R cosine of theta plus alpha. Theta plus alpha. Okay, now I'm going to expand it as I did previously. Now cosine of theta plus alpha is going to be what? Well, it's going to be cosine of theta, as I wrote down here in the previous lecture. You can use that as a reference. Cosine of theta times cosine of alpha. But now we're going to subtract. This is a mistake many students make, and unfortunately I was among them when I was first beginning. So cosine theta, cosine alpha minus sine theta, sine alpha. Okay. Now we can just go ahead and distribute pre-algebra thing. So r cosine theta, cosine alpha minus what? Let's hope that I read legibly. Minus r sine of theta, sine of alpha. Now many of you out there might be protesting already. Refath, I don't see any linear algebra in this lecture whatsoever. Watch out, it's going to be coming very soon and you won't even realize it when it hits you. So make sure you pay close attention. So, what have we got here? Now if you look carefully here, you should be looking at a very nice substitution. And what is that? Well, look at this. R cosine theta. R sine theta. Have we seen this before? Yes, we have. R cosine theta is, as a matter of fact, just A. Wow, it's A. So instead of R cosine theta, I can just write A cosine alpha.
Yeah.
And instead of R sine theta, I can just write B minus B sine alpha. Okay, what a genius move. That right there is the pinnacle. That right there is the pinnacle of algebraic substitution. So hopefully that was nice, and I didn't watch it up with my stuttering. So that was the end of the lesson. Now let's go ahead and take a look at our hopefully not too long exit slip.
Wait, this is a short lesson.
Yes, but we have an extremely long exit slip to compensate.
What?
Now, don't worry. If we have a short do now or lesson, you can expect an extremely long exit slip. Now, what was I saying?
The lesson was supposed to be long. And the exit slip isn't the exit slip just like a comprehensive check?
Yeah. Okay, so now in our exercise, what we're gonna do is take a look at B prime, right? We expanded A prime previously, and we expressed A prime in terms of A, B, and alpha, right? So let's just go ahead and write it down so that our audience doesn't get confused. Okay, now hopefully I can erase this because you've kept this in your notes or wherever you keep that kind of stuff. And we're gonna go ahead and expand B prime now. Okay, so let's go ahead and expand B prime. And you know what? I think all of this is worth writing down on the right hand side here so that we have it handy for reference. So R cosine what? R cosine theta. B is R sine theta. What about A prime? A prime is quite simply gonna be R cosine theta plus alpha, and B prime is going to be R sine theta plus alpha. Okay? Now, what is our exercise concerned with? What are we going to do in our exercise? Okay? Well, in today's exercise, what I want you to do is the following. So, go ahead, make sure you're listening carefully because I will state the exercise verbally simply because we don't have enough space to write it down. So, for today's exercise, what I want you to do is go ahead and apply the same approach I just used to expand cosine of theta plus alpha to expand sine of theta plus alpha. In other words, go ahead and expand B prime in terms of A, B, and alpha. Go ahead and good luck, and I'll give you a few seconds to go ahead and try out that do now.
Have to do now?
Sorry, exercise because I get a little bit mixed up. So hopefully that was enough time.
You can do one more. Give him the computer, he will check it.
So go ahead and
And the line.
What? Oh.
Yeah, do some distance.
yeah, okay. But we're not done here. We're almost done with the exercise. Hopefully that was enough time. I'm gonna go ahead and
The answer.
Where are you going?
give you the answer. So we have B prime is equal to R of sine theta plus.
Excuse me, instructor.
Yes.
Can you give us
Oh yes.
Yeah, I need to take
Of
an
course.
online test.
Of course, I'll give you extra credit.
No, sorry, I need to take an online
Yes,
test.
extra credit. Here you go. So R times sine of theta plus alpha, and how are we going to expand that? Well, just like we did previously, except now we'll be using the trigonometric identity for the sum of sine of negatives. Okay, so we're going to have what? Sine of theta. What is it? Now I already forgot what I wrote half a second ago. Sine of theta, cosine of alpha, and then I'm going to add it to sine of alpha, cosine of theta. Okay, and of course I'm going to distribute as previously so that I have something nice to work with. Also, I'll have r sine of theta, cosine of alpha, plus r what? Am I messing anything up? R of sine theta, cosine alpha, and then what do I have? R cosine theta, sine alpha. Make sure I didn't make any mistakes. If I did, just go ahead and comment down below. Okay, continuing with my proof for the derivation of the rotational matrix. Oh, this is part 2, by the way. I should have mentioned that. Okay, part 2. So, now you should be looking just like we did before in the lesson at a very particularly nice substitution, right? If you look very carefully, you'll see that I have r sine theta here. And we've seen that before. R sine theta is simply b. So I'll have b cosine alpha. And then what? Plus r cosine theta, but I've seen that before. R cosine theta is just a. So I'll have plus a, I'll just have a sine alpha. A sine alpha. And boom. That right there is my b prime in terms of my original vector AB and my angle alpha. Okay, so that's the end of today's exercise. In our next lecture, lecture number 76, we will be formalizing what we just did today. If this wasn't formal enough for you, we're going to be introducing the rotational matrix in lecture number 76. So thank you for watching.
Subscribe to Bari Science Lab to fall in love with math and science, especially programming.